Welcome everybody. In this video, I want to do an introduction to scientific notation. So first of all, what is scientific notation? And basically, scientific notation is a way for us to write very large and very small numbers. That's really what it comes down to. It's a way for us to write numbers that are really large, numbers that are really small. Particularly, this is helpful mostly in the sciences. So if you think about outer space, the numbers there are so huge. Or if you think about things like viruses, right? The numbers there could be so small. Looking at the size of a virus, if I'm talking about the weight of it or its diameter, if I'm talking about maybe if a virus has circular shapes or a bacteria or something like that. So these could have very large and very small numbers. So it's a way for us to kind of quickly write those. It's a shorthand. So formally, this is what it looks like. So a positive number scientific notation All right, so here's a definition. It sounds quite complicated. It's really not as bad as it sounds. So it says a positive number is written in scientific notation if it is written as the product, so meaning multiplication, of a number A, where A is between 1 and 10. It includes 1, but excludes 10, and an integer power R. So in scientific notation, the number looks like this. It's a number times 10 to some power. And now we do say, here your definition says it's a positive number A, but it works the same way for negative numbers. So you could also do negative numbers here as well. Okay. So for examples, we can write the mass of a proton as 1 65/100 times 10 to the negative 24. Or we could write the distance between the sun and Pluto as 5.906, so 906 thousandths, times 10 to the 9th power. Okay, so I want you to notice a couple of things. In each case, that first number, it can be an integer, it doesn't have to be, it can have decimals. We typically don't use fractions here. We typically use decimals, although I guess fractions would not be incorrect. But that first number is between 1 and 10. So it could equal 1, but it has to be strictly less than 10. And then you're multiplying by 10 to some exponent. Now we do typically use our kind of old school regular multiplication symbol here. We don't usually use the raised dot as much. We tend to use that old X symbol because we're not usually working with variables in this case, or at least in the scientific notation. So that's what it's going to look like. So let me point out a couple things here. Okay. So your exponent is negative for small numbers, and your exponent is positive for big numbers. And we can go back and forth between the numbers written in scientific notation versus just standard form. So standard form just means like as a regular number. So for instance here, so let me do this example here, and then I will show you how to convert back and forth. But you have 5 and 906 thousandths times 10 to the 9th power. So what that looks like as a regular number is, let's see, okay, is that number right there. Okay, so you're looking at 5,906,000,000 is the actual number. Now for the other one, this is going to be a little bit harder to write. It's going to be very small. All right, so I'm going to start my number over here because it's going to be really small. Let's see. So 2. I'm gonna run out of room. 1, 2, 3. Okay, so that's it right there. There's my decimal point. I can't even fit in the extra 0 liter. So it's 23 zeros and 165. So that would be the number in standard form. And you can see that these numbers, I mean, they're really tedious to write out and they're really easy to make mistakes as well. So sometimes with really large and really small numbers, to write them in standard form is not only tedious, but it's very easy to make mistakes. Like what if I just was typing and I missed a 0? It's really hard to count that on the screen and to make sure you have the right number of zeros. So a lot of times we'll use scientific notation for ways to write these really large and really small numbers. So now let's talk about how to go back and forth between the two. So we're going to do it this way first. So how to go from standard form to scientific notation. So that's the direction I want to talk about first. All right, so your first step is you're going to move the decimal point in the original number to create a number between 1 and 10. So remember, 1 is included in the options, but it must be strictly less than 10. Okay. Next, you're going to count the number of places you moved the decimal. Just right. This will be your exponent. If the original number was small, so less than 1, the exponent is negative. If the original number is big, so greater than or equal to 10, the exponent is positive. Now, I will say I like to teach scientific notation using the idea of big and small numbers. There are some videos and there are some textbooks that will teach it with direction of, well, if you move to the left, use this sign. If you move to the right, use that sign. And I find that confusing because the answer changes depending on if you're going from standard to scientific or scientific to standard. So I think it's really easy to mix up the two directions and remember which sign goes where. So I like to just think about big numbers and small numbers. If your original number was big, the exponent's always positive. And if the original number is small, the exponent is always negative. So if you can keep that straight, then you don't have to think so much about right or left. You just think about big and small numbers. So let's do a couple examples here. So here I have 365 billion. I want to write this number in scientific notation. So the first thing I need to do is to create a number between 1 and 10. I can include 1, but it has to be strictly less than 10. So you just sort of play around and figure out, well, where can I put my decimal point to make it between 1 and 10? And if I kind of play around here and stick my decimal point different places, I see that if I put it right here between the 3 and the 6, that would give me 3.65, which is between 1 and 10. So you just kind of play around to find that right spot. So my starting number is 3.65. And it's going to be multiplied by 10 to some power. It's always multiplied by 10. And now your second step is to count. So my original decimal point, I know it wasn't written in, it's always at the end though, right, of a whole number. So how many spots did I move? I moved 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spots. Okay. So that is going to be your exponent. Okay. And this number is big, so my exponent is positive. So I'm just going to put a positive 11 here. And that's it. Let's do another one. I'm going to do 2,000. I know 2,000 is not really that difficult to write out, but we're just going to practice here. So the first thing I need to do is stick my decimal point somewhere to make it a number between 1 and 10. So if I try sticking it here, I get 200. Here I get 20, but if I stick it right there, I get 2.000, which is definitely between 1 and 10. Now, if you want to write the 0.000 in to start, you can, but you don't need it. So the zeros aren't going to make a difference. So I can just write this as 2. And it's going to be times 10 to some power. And here, your original decimal point in a whole number would be on the end. So you have 1, 2, 3 spots. And again, this number is a big number, so my exponent is positive. So it's going to be positive 3. Let's go the other direction now. So let's say I have a small number, 0.0024. And again, I want to write in scientific notation. So my first step is just kind of play around and find out where to put my decimal point. Well, if I put it here, that's 0.245, that's too small. If I put it here, that's 2, so I kind of forget about the rest. 2.45, that looks good. If I put it between the 4 and the 5, that gives me 24.5, that's too big. So you just gonna have to play around and then rewrite that value. And now I'm going to, sorry guys, it's my puppy alert over there. And now we're gonna count. So how many decimal places have I moved? Let's see, I was using blue, let's use blue. So here my decimal point was here, it was given this time. So I moved 1, 2, 3 places, right? And then my original number was small. So my exponent is negative. So it's going to be times 10 to the negative, and then 3. Let me do one more of a small number. I have to go to the next page here. So again, the first step is to move the decimal point, so I get a number between 1 and 10. Now here, what most people do is they try to put the decimal right here, right? Because you're like, well, that's my last digit. But if I put it between the 0 and the 6, I get 0.6. It's too small. I actually have to move it to the end here, because then if I get rid of those zeros, I get the number just 6. So you want to be careful, really like place that decimal and really think about it or rewrite it and make sure that number is between 1 and 10. 1 can be counted, but 10 is too big, so it's got to be strictly less than 10. So this is going to just be 6. And then I moved it 1, 2, 3, 4, 5, 6 spots. And my original number was small. So I'm going to use a negative exponent. So negative 6. It's not always the case that the number spots equals your final number. It just happened to work out here. So this 6 is because of this number 6, and that 6 is because I had to move the decimal 6 places. So now let's go the other way. So let's say I'm in scientific notation. And I want to get back to standard form. Right? So maybe I'm giving a presentation, and maybe I'm talking to students who don't really understand scientific notation. So maybe I want to go back to my work and convert them back to standard form so that I can give a presentation to students who would not know about scientific notation, right? Or someone who's not in the science community. So how do you convert back over? And again, it's gonna be a very similar process. All right, so what did I use? Step 1? Yeah. Okay. So you're gonna move the decimal point the same number of places as the exponent. If the exponent is positive, create a big number. And if the exponent is negative, create a small number. And really that's basically it, right? So when we have a power of 10, we're really just multiplying here or doing dividing. So you're either moving your decimal right or left in this case. So let's do some examples. So I have 1 and 45 hundredths times 10 to the 7th. I want to go back to standard form. So I'm going to notice a few things. So I am going to notice that 7, right? So 7 means I'm going to move the decimal 7 spots. And it's positive, so I'm going to create a big number. So if you think about this here, let me rewrite it. So I'm going to rewrite the 1.45. I need to move my decimal 7 spots. Now, if I want the number to be big, do I move my decimal to the right or do I move my decimal to the left? So think about it for a second. If I move my decimal to the right, what happens? If I move my decimal to the left, what happens? And at the end of moving, that's where your decimal place goes. So to create a big number, what's going to happen is you're going to end up moving right. So I go 1, 2, and then I need 7. So 3, 4, 5, 6, 7. And then we're going to fill in any holes with zeros. 1, 2, 3, 4, 5. So this number is 14,500,000. So again, same idea here. I'm going to move 5 places, right? And then because it's positive, I need to make a big number. So I'm going to end up going to the right here to make a big number. Now I like to rewrite, and your decimal point, don't forget, is on the right. So you have to fill that decimal point in for whole numbers. And I'm going 5 spots to the right. 1, 2, 3, 4, 5. And I fill in any holes with zeros. So in this case, I have 400,000. Okay, let's do 2 more examples going the other way. So 1 and 237 thousandths times 10 to the negative 4. So here I'm going to move 4 spots. And the negative exponent means to create a small number, right? So think about this. If I want a small number, which way do I move the decimal point? Well, it's going to go to the left in this case. So for this particular problem, we're going to the left. And I'm going 4 spots. So 1, 2, 3, 4. And I fill in any other holes with zeros. So my answer is 0.00012337. And again, you can always attach that leading 0 for the whole spot there. So let's do 3 times 10 to the negative 5. So again, we're moving 5 spots here. And the exponent is negative, so I want a small number. So I'm going to end up moving to the left in this case. Now remember, if you have a whole number, your decimal point is on the right. Now I move 5 places. 1, 2, 3, 4, 5. And my final value, 1, 2, 3, 4. And I can put that leading 0 just to make it a little bit more finished. All right, so that's how it works. The positive exponent represents very large numbers. That negative exponent represents very small numbers. If you can kind of keep that straight, then you should be able to convert back and forth, really just using that idea. If you prefer to always remember and write yourself left and right directions, you can do that. You just want to be careful because it just changes, right? So when we're going to a standard form, we're moving left for small numbers or right for big numbers, but when we're going the other way, it flips. So just be careful with the kind of right-left idea. And again, I recommend thinking about big and small. How do you get big numbers? How do you get small numbers? So hopefully that was helpful here. And like I said, it is really helpful, particularly in fields where they do work with very large or very small numbers often. It's helpful just in the writing purposes, and it's also helpful in computations, which we'll see in the next video.